All right, so continuing with chapter 5 and applications of the derivative. In this video, we're going to talk about what are called the higher derivatives. And by higher derivatives, we just mean we're going to take the derivative of a function. We call that the first derivative. And then if you take the derivative of that, then we can start talking about the second derivative. And you can continue and take the third derivative and the fourth derivative and so on. Nothing really new about it as far as process. The way you take the second derivative is the same way you take the first derivative. Sometimes you might have a different type of function. So for instance, you take the first derivative of a ln function, you end up with 1 over x, which is rational. So the way you take the derivative, I guess, could be different, but however you would take the derivative if that was the original function is how you take the second derivative or the third derivative and so on. So let's look at a couple of examples here. So first off, let's talk about notation. So we can either write like this. So the first derivative, we have the first derivative, we might write that as f prime of x. If we have the second derivative, we might write that as f double prime. So we just write 2 primes instead of 1. And if you want to write the third derivative, you could write 3 primes. Above that, typically we're going to write, I guess we call this the nth derivative. You don't make that many marks, 4 marks, 5 marks. You would put f in parentheses, or f4 in parentheses, f5, so on. Or the other way, we've seen this notation for a derivative. This would be a first derivative. A second derivative is written like this. So you have d squared y dx squared, and then beyond that, you just replace the 2 with whatever number derivative you are on. All right, that's just notation. Mostly, I think we'll probably see f double prime of x like this. So let's find the second derivative of this function. Just a very easy polynomial. So let's take the first derivative just like we know how to do. So we use the power rule on each of the 3 terms. So you have 20x cubed minus 12x squared plus 3. And then to take the second derivative, you just do the same thing. So you use the power rule again. So we have 60x squared minus 24x. And so if I gave you this function and said find the derivative, you would find the derivative just like we just found the second derivative, with this being the first derivative. So no real mystery here, no real twists or turns. It's kind of, if I said find the second derivative and you had never heard of that, but you know how to find the first derivative, it probably makes sense just to do the same thing you did the first time. All right, so let's look at another example. Maybe overkill this a little bit, but that's okay. So first derivative, f of x equals x cubed plus 1 squared. So we're going to use the power rule, chain rule actually, I guess. So bring the 2 down. We have x cubed plus 1 to the first power times the derivative of x cubed. So now let's simplify this. And we will get 6x squared times x cubed plus 1. Now you can maybe start to see with this one, when you start taking the derivative over and over again, you still have the same type of function. If you distribute this, you still have a polynomial. But if you want to take the derivative of this, you're going to have to use the power rule. Now maybe this is not a big deal to distribute, so maybe we'll just distribute this. And now it'll be easier to take the second derivative. But sometimes you may not be able to do that. For instance, if this was x cubed plus x, now we'd have a 3x squared plus 1. Then maybe you have to start foiling. If this is a higher exponent, it can get a little bit tricky. The second, third, fourth derivatives can get a little bit complicated to do. Especially, I mean, you can imagine maybe if you have to use the quotient rule, if you have to do the quotient rule multiple times, that can get a little bit tedious to do. But this one's not too bad. So let's take the derivative of this. We get 30x to the fourth plus 12x x. There is our second derivative. All right, so next one, another example, x e to the x. Find the second derivative, so let's find g prime of x. I'll have to use the product rule, so this will give us e to the x plus x e to the x. So take the derivative of x, hold e to the x constant, so that's just e to the x. And then we switch, take the derivative of e to the x, hold x constant. So we get x plus x e to the x. So now the second derivative of e to the x is just e to the x. And then the derivative of this is just going to be what we just did. So we'll just write e to the x plus x e to the x. And then we can combine these two. We get 2 e to the x plus x e to the x. And that's fine. You can factor out the e to the x, I guess. E to the x times x plus 2. Either way is fine, I think. All right, and then one more example, and then we'll look at an application of this. So find the second derivative of ln of x divided by x. So now we need the quotient rule. So h prime of x, we have the bottom times the derivative of the top minus the top times the derivative of the bottom, which is just 1, all over the bottom squared. And then let's simplify this. X times 1 over x is 1 minus ln of x over x squared. And then let's take the second derivative. We got to use the quotient rule again. This time, the quotient rule doesn't really get too much more complicated. We got a little bit more on the top, but not really a big deal. So we have the bottom times the derivative of the top minus the top times the derivative of the bottom. That'd be 2x. All over the bottom squared, x squared. Squared is x to the 4th. So then distribute or multiply this out. So we get negative x there minus 2x plus 2x ln x over x to the 4th. Let's combine our like terms. We get, and we'll write the positive term first, 2x ln x minus 3x over x to the 4th. And then we can divide out, we factor out an x on top. So we get x, 2 ln x minus 3 over x to the 4th, and then x over x to the 4th gives us an x cubed on the bottom. So 2 ln x minus 3 over x cubed, and there is our second derivative. Okay, so you can see if you know how to take the first derivative, you can take the second derivative. It's usually no new rules or anything like that. Sometimes maybe it gets a little bit more complicated as you go, but it's mostly just simplifying the algebra. It's not really any new hard calculus. All right, so let's look at velocity and acceleration. So velocity is going to be represented by the first derivative. So we have the distance in feet of this car is given by this function here. And this is the position function given some time t. The derivative of this position function is your velocity. So let's take the derivative. We get 3t squared minus 6t minus 24. Then the second derivative is acceleration. So acceleration is going to be s double prime of t, or we could write this as v prime of t. But we're going to take the derivative of this to get the acceleration, and that gives us 6t minus 6. All right, so now let's talk about these other two questions. When is the car going forward, and when is it backing up? And then when is the car speeding up? When is it slowing down? First question, when is it going forward or backing up? It's going forward, so forward means the velocity v of t is positive, and backward or backing up means v of t is negative. All right, so let's see when v of t is negative. So let's set this equal to 0. So 3t squared minus 6t minus 24 equals 0. Let's figure out where it's 0, and then we can test our intervals. Let's divide out the 3. So we get t squared minus 2t minus 8 equals 0. T minus 4 and t plus 2. So that gives us t equals 4 and t equals negative 2. We're going to assume that t is positive because it doesn't really make sense to talk about negative times. So there's where t equals 0. Now let's test our intervals. So we put 4 there. And if t is less than 4, is this going to be positive or negative? If t is greater than 4, is it going to be positive or negative? So let's plug in 0. And if we plug in 0, so test point, t equals 0, v of t, or v of 0, I should say, is just going to be negative 24. So this is negative. Next test point, pick a number greater than 4, so t equals 5. So v of 5 is 3 times 5 squared minus 6 times 5 minus 24. So that is 25 times 3 minus 30 is 45, minus 24 is 21. So that one's negative, this one's positive. So backing up from 0 to 4, stopped at 4 because the derivative is 0. And then going forward from 4 to infinity. So backing up at the beginning and then get to 4 seconds, and then you start going forward. All right, now let's look at acceleration. Now, you might think, when is it speeding? Is speeding up when acceleration is positive, slowing down when acceleration is negative? That's actually not correct. It is accelerating because you can accelerate going forward, you can accelerate going backwards. Just because you're going backwards doesn't mean you're decelerating. You're accelerating when your speed is going up, and speed has nothing to do with direction. Velocity is speed and direction. So if you're going forward and you're accelerating, that means you're going faster in that direction. If you're backing up and you're accelerating, that means you're going faster in that direction. So the car is speeding up when v and a, so velocity and acceleration, have the same sign. So either they're both positive or they're both negative, because if you're going backwards, velocity is negative, and if acceleration is negative, that means it's going faster in that negative direction. Then slowing down means that v and a have opposite signs. So let's see where v changes. This is fairly easy to do. So we set that equal to 0. We get t equals 1. So then we can test this. Put 1 there. Of course, we have 0 here. Pick a number less than 1. So if you pick 1/2, say t equals 1/2, that means that a of 1/2 is going to be negative. And if you pick a number that is greater than 1, so plug in 2, 6t minus 6, that's going to be positive. So a of 2 is going to be positive. Okay, so now what are the intervals where we have the same sign? What are the intervals where we have different signs? So I'd kind of like to make a table of this. So let's make our intervals here. So we have 0 to 1. So 1 and 4 are the critical points. We start at 0 because we're talking about time. 0 to 1, 1 to 4, 4 to infinity. So 4 is the critical point with the velocity, 1 is the critical point with the acceleration. We need to consider both. So now let's look at velocity, and we're just worried about the signs here. From 0 to 1, actually we could just say from 0 to 4, velocity is negative. So this one is our velocity. So we have negative, negative. From 0 to 4, velocity is negative. And then after 4, velocity is positive. Acceleration is negative from 0 to 1, and then positive from 1 to infinity. Okay? So this car, so here we have the same signs, here we have different signs or opposite signs, and here we have the same signs. So we are speeding up from 0 to 1 there, and this is going in the negative direction, but it's still speeding up. And from 4 to infinity. And then we are slowing down between 1 and 4. Okay, and it kind of makes sense. If you think about it, you're probably at rest. And then you have to speed up a little bit. You back up, you speed up when you start, and then you slow down until you come to a stop at t equals 4, and then you speed up, and then you go. Okay, so that's the velocity and the acceleration. Remember, velocity is the first derivative, acceleration is the second derivative. Going forward, velocity is positive, backing up, velocity is negative. And then speeding up means that velocity and acceleration have the same sign. Slowing down means they have opposite signs. And I kind of like this idea of the table here because it gets a little bit confusing, especially if you start getting more intervals. 3 intervals is not terrible, but once you get more than 3, maybe it gets a little bit tricky. So I like the idea of the table. It helps you keep things straight. All right, so that we'll stop here for this one, and we'll continue the rest of this section in the next video.